Hi there, so this is the third video on universes and predicate validity, and this time instead of seeing me, we're just going to go straight through the slides. I think that will make it easier. Alright, so we've just talked about how universes can help us show formulas to be true or false, so we can show consistency or contingency. What we want to now show is that universes can also help us show validity and invalidity. So just to remind you, to show that an argument's invalid, we have to show that it's possible for the premises to be true while the conclusion's false. So that argument below, we'd have to show that 1 could be true while C could be false. Put another way, to show that the argument above is invalid, we need to find a universe that simultaneously makes the premise true and the conclusion false. So it's sort of a universe that's doing two things at once. It's making the premise true and the conclusion false. Now, likewise, to show that an argument's valid, we would have to show that there aren't any universes where the premise or the premises are true and the conclusion is false. Now, it turns out it's quite a bit harder to show validity than it is to show invalidity, and for a pretty basic reason. To show that an argument's invalid, you have to only find one universe, a universe that makes the premise true and the conclusion false. To show that an argument's valid, you have to show that out of all the infinitely many universes, there's none where the premises are true and the conclusion is false. There are methods that we could devote to, or that we could develop to figure out validity in that way, but it's a little bit hard for us. So we're going to focus on these slides and in this class on showing invalidity with universes. I think it's best just to get to an example. So let's consider the example we've got right before us. The argument we just saw has one premise. It says there is an x such that px, that is, something is p, and the conclusion says, therefore, a is p. Now I'm just going to tell you right off the bat that this argument is invalid. What we want to do is try to come up with a universe that displays its invalidity, that establishes that it really is invalid. To do that, we need to come up with a domain and an interpretation, in this case an interpretation of the predicate p and the name a, that makes the premise true and also simultaneously makes the conclusion false. There's lots of right answers here, but here's one that works. Let's let our domain contain all things. And let's let our interpretation of p be the property of being female. That is, px says of x that x is female. And let's let a, the name a, refer to LeBron James. If you think about it, you'll see that this demonstrates that the argument's invalid. That's because with this interpretation and that domain, the premise says there's at least one female, which of course is true. Out of all the things there are some females. While the conclusion says that LeBron James is female, which is false. He's not female. So this universe, that domain and interpretation you see below, that establishes that the argument is invalid because it's a way of showing that the premise could be true while the conclusion's false. Let's next look at a slightly more difficult example. Consider this argument, much more complex than the last one. The first premise says nothing is both p and q. The second premise says all q's are r's, or every q is an r. And the conclusion says, therefore, no p is an r. So again, I'm just going to tell you off the bat that this argument's invalid. You might have worked that out with a Venn diagram or in some other way, but for this activity, we're just going to assume, or not assume, but just start off with the information that the argument's invalid. And again, our job is to come up with a universe that demonstrates this invalidity. So again, what we're trying to do is come up with a domain and an interpretation. In this case, we've got to interpret p, q, and r in such a way that that interpretation and that domain makes those both premises true while also making the conclusion false. And I find that in these more complicated examples, it's sometimes nice to start with actually the conclusion and trying to make the conclusion false and then sort of work backwards from there. So take a look at the conclusion. The conclusion says nothing is both p and r. So to make that false, we need to come up with a domain and a p and an r so that there is actually something that's p and r. That would make the claim that nothing is p and r false, which is what we want. We want a false conclusion. So again, there's lots of things you could pick, but just for an example, suppose we let our domain be people, then we just need to pick a P and an R where some people have both those properties. So for instance, P might be the property of being a father, and R might be the property of being a mammal. Since some people are both fathers and mammals, it follows that the conclusion would be false. That is, what we've got so far is this. We've set our domain to people, we've let Px mean X is a father, and Rx mean X is a mammal, and we can see that that's going to make our conclusion false. So let me fill in sort of what these say now. We see that the conclusion says no fathers are mammals, and that's false because some fathers are mammals. What we've next got to do is figure out what Q is going to be. We know that premise 1 says no father, because that's the P, is a Q. We don't have an interpretation for a Q yet, so that's blank. And we know that the second premise says all Qs, that is the blank there, are mammals. So we need to think of a Q that can fill in those blanks that makes both those sentences true. So we want some property Q such that no father has property Q, but all Q have the property of being mammals. So it's a little bit of a puzzle to try to figure this out. And again, there's lots of things that would work, but here's what I did. I let Q mean X is in preschool, or X is a preschooler. And then we get the following. No father is a preschooler. That's true. Premise 2, all preschoolers are mammals. That's true because all preschoolers are humans and all humans are mammals. Therefore, no fathers are mammals, but of course that's false. So this interpretation, together with the domain, shows us that the argument's invalid. It shows that it can have true premises and a false conclusion. All right, that's all for this video. There's some practice problems in the book that you want to run through, and also in the homework, so make sure you understand how to show that invalid predicate arguments are invalid by giving universes.